Hello friends, welcome to a fresh new episode of our channel RG Innovations. If you have not subscribed already, please subscribe to our channel, click on the bell button and select all to get all future notifications of our video uploads. In today's video, we are going to learn about Modulated IR Sensor module. In our previous video, I have shown you normal infrared module which detects proximity or obstruction in front of that. But that module has a limitation. It does not work in sunlight because sunlight also has infrared light in it. So that infrared light is received by the sensor and then the module gives a wrong or false output. Unlike the previous module, this module does not use static infrared light for the obstacle detection. It uses a modulated infrared light that is emitted from this infrared LED and is received by this TSOP1738 infrared receiver. TSOP means thin small outline package. So this 1738 TSOP infrared sensor receives the modulated infrared light and it works irrespective of the presence of sunlight or any other sources of light. So this module is far better than the normal infrared modules. This module also pretty similar with the normal infrared module, but it has two potentiometers. One of the potentiometers are for the adjustment of frequency of the infrared LED and the other potentiometer is for the adjustment of the distance from the sensor to the obstruction. This module uses a NE555 IC for the modulation of the infrared light, and this module does not use any comparator IC. The TSOP sensor itself gives the output. The 1738 TSOP infrared sensor works in 38 kHz. So the LED frequency is also adjusted to 38 kHz by the 555 IC. This module has 4 connecting pins. The first one is the ground pin. The second one is the positive power supply pin. The third one is the digital output pin. And the fourth one is the enable pin. This module works in 3.3 volt to 5 volt DC range. Giving any higher voltage can burn the module. We can see a jumper in this module. If we remove this jumper, we can program this module for enabling the sensor or disabling the sensor from a microcontroller by this pin. If we give positive power supply to this pin, this module enables, and if we give negative power supply to this module gets disabled only when this jumper is removed. When this jumper is attached, this enable pin has no function. I personally don't see any use of this enable pin and this jumper. These 3 pins, the first 3 pins are enough for this module to work properly. This module also has got 2 LEDs. One of the LEDs are used as a power supply indicator and the other is used for showing the output status. This module also is an active low module. That means when the obstruction is detected, the output is low, and when there is no obstruction, the output is high. But the LED shows in an opposite manner. When it detects an obstruction, the LED turns on and the output is low, and when there is no obstruction, this LED turns off and the output becomes high. So that is all the theory we need to know about this module. Now we will see the practical demonstration of this module. I will show the demonstration on a breadboard. So I am bringing in a breadboard. I have connected 2 power supply wires. The red one is the positive power supply and the white one is the negative power supply. It's connected with an external 5 volt power supply. Now I am inserting the module on the breadboard and I am connecting the power supply wires from the power rail. The first pin is the ground pin and the second pin is the positive power supply pin. So you see, as soon as I connected the power supply wires, one LED is glowing prominently, the power indicator, and the sensor LED is blinking. So you need to adjust the potentiometers. Now this potentiometer is for the frequency adjustment, that we need to adjust the modulation of this IR LED, and this one is for the sensitivity adjustment. So if I bring my hand closer, it is not working now. So we need to adjust the potentiometers. So we need to adjust both the potentiometer to see exactly where it works perfectly. So we have adjusted. Now we see, as I am putting my hand closer, this module is detecting the obstacle and showing the output status by turning the LED on. Now this distance can be adjusted as much as 30 to 40 centimeter depending on the obstacle or obstruction color and the environment light. We need to adjust this potentiometer to adjust the sensitivity of the module. So now this module is working perfectly. Now we will connect an LED and see the output. Since this is an active low module, we need to connect the negative with the output pin and the positive to the positive power rail. So I'm connecting the anode pin of the LED to the positive power rail and cathode pin on the breadboard. Now I will connect the output pin to the cathode pin of the LED. Now if I bring an obstruction to the module, you see the LED is turning on. So this way we can connect the modulated IR sensor with a relay to operate higher loads. This module can also be used in any proximity sensor based projects like automatic hand sanitizer, like obstacle avoiding robots, like line following robot, or any project of the similar kind. So this is the standalone operation of the infrared module, and now we will see its connectivity with an Arduino. Forgot to mention, these modules are also very cheaper. It comes within $1 or less than $1 price, so we can use it in our projects. Now I will show its connectivity with an Arduino. So we will use the Arduino now. So here I bring the Arduino. I am increasing the visible range. Now we will connect the LED with the Arduino. The anode pin of the LED will be connected to pin number 13 of the Arduino, and the cathode pin to the ground pin of the Arduino. So this is now connected. We will take the power wires to the Arduino, the positive and negative pin, and we will connect the output pin of the IR module to Arduino pin number 2. And now we will upload the sketch on the Arduino. So this is the Arduino sketch that we will upload on the Arduino. We have selected the IR pin, that is the input pin, pin number 2, digital pin 2, and the LED pin is pin number 13, that is digital pin 13, where we connected the LED to show the output status. Now we will upload the sketch. The COM port is selected for the Arduino board is selected. And now we will upload the sketch. So compiling the sketch uploading done. We have connected the LED in the wrong direction, so it was not glowing. Now we are connecting the anode to pin number 13 and cathode to ground pin. Now you see, as we are obstructing the infrared sensor, the LED is glowing. See, whenever it detects an obstruction, it glows. So in this way we can interface the IR module with the Arduino. So this much is for today. If you have any question or any query about this IR module or interfacing it with Arduino, please ask me in the comments. I will answer, and in our next project I will come up with a different module. If you have not already subscribed to my channel, please subscribe to my channel RG Innovations. Your subscription will give me more enthusiasm for bringing new videos. So thank you for watching. We will meet again in a new video. Till then, bye bye, take care, have a nice time. Thank you.